So next, we need to still form the carbonyl, and we need to get rid of this hydrogen that's still on the carbon. So we're kind of going to do the same thing we did before. We are going to take chromic acid, and we're going to have one of the hydroxyl groups attack it. I know I don't have a lot of space. So, and kick off one of the hydroxyl groups on the chromic acid. And let's go up here. So now we have one of these hydroxyl groups connected to chromic acid. And that's going to have a positive charge. This is getting really small. So we're going to need to deprotonate that. We can use the hydroxyl group we just kicked off chromic acid to do that. Get rid of that positive charge. And now I'm going to go here. That. And we have, I'm just going to write CrR3 for simplicity. And so now we can take off that hydrogen. We can just use water. Take off the hydrogen. Form that, excuse me. Take out the hydrogen, form the double bond between the oxygen and the carbon, and then kick off the chromium group. And then that would get us to the product of really long mechanism. All right, now we have fill in the blanks. So we're going from a carboxylic acid to an alcohol, so it's a reduction. I believe we did a reduction on the previous page. Yeah, lithium aluminum hydride. So that's how you're going to go from carboxylic acid to an alcohol using lithium aluminum hydride. Oh, that should be a 4. Then an acid quench. That's how you do that. And next, we're going from an alcohol to an aldehyde. So we're doing an oxidation. Here we did a reduction to start. And now we're going to do an oxidation. Our two options for oxidation is we can do PCC and methylene, PCC along with methylene chloride. Or our other oxidation we know is the chromic acid and water. In this case, we couldn't use chromic acid and water. And the reason for that is if we use chromic acid and water with a primary alcohol, that would turn into a carboxylic acid. But we only want an aldehyde. So PCC with methylene chloride will do that. Now got to predict the products given the chromic acid reagents. So we just talked about if you have primary alcohol, chromic acid, that's going to turn it into a carboxylic acid. You have a secondary alcohol with chromic acid. That's going to then turn it into a ketone. Tertiary alcohol, chromic acid, it's not going to react. You need to have hydrogens on that carbon connected to the alcohol in order to react with chromic acid. And on that carbon on the tertiary alcohol, that has 0 hydrogen, so that's not going to react. Then when you react chromic acid and water with alkyl groups coming off the benzene ring, as long as there are hydrogens on the carbon directly attached to the benzene ring, it's going to turn those into carboxylic acids. So all three of those alkyl groups that have hydrogens directly on the carbon, or have hydrogens on the carbon that's directly attached to the benzene ring, those are going to turn into carboxylic acids. But for this tert-butyl group, because the carbon directly attached to the benzene ring has 0 hydrogens, chromic acid is not going to react with that. So that's the product you're going to get. All right, syntheses. So we're going from an alkyl benzene ring to an ester. So the only way we've learned to make esters right now is through Fischer esterification. And Fischer esterification starts with a carboxylic acid. And it's done with an alcohol. The alcohol should be this part of the ester. So if we would turn this into an alcohol, then it's going to look like that. So this is what's going to go along with the arrow. Shrink it. And then it's done under acidic conditions, so sulfuric acid. So now we got to get to the product. To go from an alkyl group to a carboxylic acid, you can just use chromic acid like we just learned up here. So H2CrO4 and water. So that's the simpler of the two syntheses. Now we have to go from this alcohol to an alkane. So I gave you the deuterium just so we can number. So we know that carbons 1, 2, and 3 are going to remain, and we have to add on carbons 4, 5, and 6. So we have to use a reaction. So because we're adding on carbons 4, 5, and 6, we know we're going to have to use a carbon-carbon bond making reaction. So we're going to have to make carbon-carbon bonds. And so far for this test, the reactions we've learned that make carbon-carbon bonds are like organolithium, Grignard. We've also learned the Vidic and using like a nitrile group or using a alkyne also, but we can kind of throw out these three because a Vidic is gonna create an alkene. We don't have a carbon triply bonded to nitrogen in the product, so we can throw away that one. And we don't have a triple bond anywhere in the product either, so we can also throw away that one. So our remaining reactions we've learned to make carbon-carbon bonds are then these two. So we're probably going to use one of these two in order to make the carbon-carbon bond. And what do these react with? Well, they react with ketones, aldehydes, and epoxides. I'm going to throw away epoxides because this test is based on aldehydes, ketones. So we're going to look to try to form an aldehyde or a ketone with our starting material. So then we can use an organolithium or a Grignard to add on these carbon-carbon bonds. So can we get this alcohol to an aldehyde or ketone? Yes, we can oxidize it. And we can turn it into an aldehyde. If you can think of the reaction that does that, you would think PCC with methylene chloride. That would oxidize it to an aldehyde. So now we can make our carbon-carbon bond. I'm just going to use an organolithium. You could use a Grignard too. So we need to add on carbons 4, 5, and 6. So let's add on carbons 4, 5, and 6. And then we're going to need an acid quench. And then what's this going to create is it's going to allow us to add on those carbon-carbon bonds. So 1, 2, 3, 4, 5, 6. We number. So now what's separating us from where we are in the product is we have to get rid of this hydroxide group. There's a number of ways you can get rid of this hydroxide group. The way I wanted you to do it, and not the only correct answer, is I wanted you to use the Wolff-Kishner reaction. The Wolff-Kishner reaction, if you remember, it's 2 nitrogens and then ethylene glycol and potassium hydroxide. And this reacts with carbonyls. So our carbonyl will be on carbon 3, and we know that because our hydroxyl group's on carbon 3. And that would get rid of the carbonyl and just put on hydrogens. So that's the reaction I would have wanted you to use because that's in the that's within the test, but you could have done other ways to get rid of the hydroxyl group. So then how do you go from how do we get from an alcohol to a carbonyl? We can just use PCC again to oxidize it. So this isn't the only synthesis you could have used to create this, but this is one of them. If you think of other ways to do it, feel free to text me and I can check them over.